In this tutorial, we are going to look at bifilar suspension, and this is a possible WAEC Physics practical examination question coming up this week. So we have two retort stands and two strings of wire with a meter rule suspended from the two strings. The length of the string are 50 cm each. So we ensure that the two strings are of the same length. They have the same length, 50 cm. So we are going to record that in meters as 0.5 meters. So we have that here. I already have the record in here, which is represented by letter H. In this practical, it is represented by letter H. In other practical, it may be represented by the letter L. So that's 0.50 meters. Then the next thing we have to do is to get the distance or the length D between the two strings. The length D between the two strings, and that can be simply done by calculating 90 minus 10. That will give us 80. So D is equal to 80 because the meter rule is suspended at the 90 cm mark here and at the 10 cm mark this way. Then another thing you have to do is to get the mass of the meter rule. So before the experiment begins, you get the mass of the meter rule by using a weighing scale. If you don't have a weighing scale, you can get the mass of the meter rule by using the principle of moment. In this experiment, I got the mass of the meter rule by taking the average of three values that are obtained for the mass of the meter rule using the principle of moment. Then after which we are going to have slot masses of two pairs each. I have 10 grams, I have 20 grams, I have 30 grams, I have 50 grams, and I have 70 grams. So each of these we are going to be putting them in pairs on either side of the meter rule. So the first 10 gram, I place it at the 15 cm mark. I place at the 15 cm mark. Place at the 15 cm mark. Then the other 10 grams, I'll place it at the 85 cm mark. So after this, I'm going to set this into a small oscillation by getting the time for 20 oscillations. So I'm going to do this. So I'll set into 20 oscillations. So let's go. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So my time recorded is 27.91. Now you may want to do this by taking 2 times T1 and T2 and taking the average. If you do that, you are going to get a better accuracy. Now the next thing we have to do is to repeat this for the mass of 20 grams, 30 grams, 50 grams, and 70 grams each on the other side with a distance between them 70 cm. So that means you are going to always place it at the 15 cm mark, and also at the 85 cm mark. Now join me as I complete the table. After completing the table, then I will plot the graph. Now these are the various time recorded for each of the masses. So when I placed 20 grams, my time recorded was 28.30. When I placed 30 grams on either side, the time recorded was 28.42 seconds, and for 50 grams on both sides I have 28.55, and the last one 70.0 I had 28.96. so these are the times recorded. Now on this column here you have the masses. Here you have arrow equals m plus 2m. I have already done the evaluations on all of that. That is simply the value of arrow is simply the mass recorded 1.115.5 grams plus 2 times this. So when you work that out, I'm going to have 131.50, 151.500, 171.500, 211.500, 251.500. Now after that we are going to evaluate arrow inverse, and the unit is going to be per gram. So how do I get that? I'll divide this value here. So I'm evaluating arrow inverse. So arrow is what? M plus 2m. Like I said earlier, to get this is m, the mass of the meter arrow, plus 2 times this mass here. So also for this. So that's how you get this, all the values on this column. Then you evaluate arrow inverse. Arrow inverse is 1 divided by all these values here. So you used to get this. Now t, you understand how we got the time for the 20 oscillation. So we have this. These are the times for 20 oscillation. Now next, we have to evaluate t equals. So we are evaluating t equals t over 20. So t equals, because we have 20 oscillations, so we are going to divide all of this by 20. So by my division there, I'm going to have 1.396, 1.415, 1.421, 1.428, 1.448. Then on evaluating t square, we square all of this. So I'm going to have 1.949, 2.002, 2.019, then I have 2.039, 2.097. So this is my composite table. Now from this you will realize that I did not read the question, but what we are asked to do are what I have just tabulated on this table. We are given the masses. We are asked to evaluate arrow equals m plus 2m. We are asked to evaluate the inverse of arrow. We are asked to get the time for 20 oscillations. We are asked to evaluate t equals t over 20. Then we evaluate t squared. Again, we are asked to record the mass of the meter arrow, to record the length of the wire in meters. We are asked to calculate the distance between the two strings, and we are also asked to calculate the distance between the two masses. Now let's plot the graph of the point. So we are going to plot the graph of t square against arrow inverse. What that means is that t square is going to be on the vertical axis, and the arrow inverse is going to be on the horizontal axis. Now all we need to do is to plot the graph of the point t square against arrow inverse. Now if you look at the values on the t square axis, on the t square column of the table, you will find out that the values are not stretched out. And if you decide to stretch them out and you want to plot on these points, you want to plot the points on this place. If you start from the origin, it is going to be very difficult for you to stretch all these values here. Now, so what I'm going to do, I'm going to start my graph. Since I have 1.94 as the smallest value here and the greatest value is 2.097, I'm going to take this and start my graph from here using 0.4. Now let's try that. 1.9. I'm going to start this using 1.9 here, and I make it a gap of 0.02 to 2 cm. If I use a scale of 0.02 to 2 cm on this, so I'm going to have if I have 1.94 here, I'm going to have 1.9 here. I'm going to have 1.92, 1.96, 1.9, sorry, 1.90, 1.92, 1.94, 1.93, 1.9, sorry, I take that again, 1.90, 1.92, 1.94, 1.96, 1.98, 2.0, 2.2, 2.22, 2.22, then I have 2.23, and we are going to end at 2.0. So I'm going to make it 2.00. So my gap is going to be 0.00. So if I have 1.94, I have 1.94, I have 1.942, 1.96, 1.98, 2.00. So we shall be going with this. So I'm going to start with 1.94 at this point, 1.94. So I'm going to go with 1.96. I go with 1.98. I go with 2.00. Then I go with 2.02. Okay, I go with 2.04. Now I have been able to mark out my points. Now the points will look very difficult on the t-square axis because they are so close to each other. So what I did is this: I'm using 2 cm to represent 0.02 squared, second square, 2 cm to 0.02 second square. Now I can't start my graph from the origin, because if I do that, I will not be able to have enough space to fill this. So that's why I'm starting this from 1.94, because the least value I have here is 1.949. So we can start the graph. It's 1.949. So we can start the graph from 1.94. Now let us get the points or the values for the arrow inverse axis. So we have 0.040 as the least and 0.076 as the height. So we can simply we can start from the other 0.00 and go 0.001. So on the arrow inverse axis, I'm taking a scale of 2 cm. I'm taking a scale of 2 cm to 0.001 per gram. So you have this. So you can see, it's not clear now. So you can see 0.010, 0.020, 0.030, 0.040, 0.050, 0.060, 0.070, 0.080. Now we can plot the points. Now we know that when t squared was 1.949, we had our arrow inverse was 0.076. So we read this off here. So I have 0.07. So the 6, I have 0.07 here. So 6, I'm going to have 1, 2, 3, 4, 5, 6. So I'm going to trace this upward. I'm going to trace it upward to 1.94. I'm going to trace it that to 1.94. So my 1.94 should be around this area. So this is 1.94. I'm reading 1.949. So this is 1.94. This is 1. Now the gap between this is going to be, I have an 1.96 minus 1.94, that's 0.02, divided by all of this point here, which is 10, divided by 10, that's 0.002. So it means that each of these smaller lines are 0.002. So for me to get 1.94 of this is 1.942, 1.944, 1.946, 1.948, 1.995. So but I'm looking for 1.949, so it's going to be in between this. So let me just trace this. So I have 1 2 3 4, 1 2 3 4, in between 4 and 5. So let me go back to this. So I have 1 2 3 4 5 6. So I have to count this upward. 1 2 3 4, in between 4 and 5. So I put this and I draw my circle. So we trace out there. Now take note, I said that the gap between these two lines on this is 0.002. So I'm going to have this. Then we go for the next one. So I have 2.002, 2.002. Then arrow inverse is 0.0066. So we can easily read off that. So I'm going to count this out. 1 2 3 4 5 6 this way. So I'm going to read 2.002. So I can get 2.002 of this. So that would be very close to 2.00. So I read it off and trace it to this side, to this point here, 6. So I count 6 places this way. 1 2 3 4 5 6. So I'm going to put this here. Then for the next, I'm going to have 2.019, 2.019, 2.019. Then I have 0.058. I have 0.058. So I'm going to read 0.058 off here. 0.058 off here. So I have 0.05. So I have 1 2 3 4 5 6 7 8. So I have to trace it up to 2.019. So this is 2.02, 2.019. So this is 2.002, 2.004, 2.006, 2.008, 2.010, 2.010. So 2.019 is in between this. So I have to trace it up this way to 55. So this is 50. 1 2 3 4 5. So I'm going to put my point here. Now mark this out. And the next is 2.039 for 0.047. So again, let me get 2.039 of this. So this is going to be 2.02, 2.04, 2.06, 2.08. Then I have this is 2.022. So this is 2.022, 2.024, 2.026, 2.028, 2.028, 2.028. So I'm going to have 2.03 at the midpoint. So I have 1 2 3 4 5. This is 2.03. Then I have to get 9 of this. So 9 is going to be midway between this and this, this and this. So I have to trace it to 50. That's 0.5, 0.5 0.47. Yes, I'm going to change to 0.4. So this is 0.4. 1, 2, 3, 4, 5, 6, 7. So I have this here, and I draw this way. Then the next one is going to be, so the last point, I have 2.097 for 0.040. So I'm going to get 0.040. I'm going to get I'm going to get 2.097 for 0.0040. So this is 4.0040. I'll trace it up. I'm going to 2.097. So this is 2.08. 2.08. So this is going to be 2.082, 2.084, 2.086, 2.088, 2.088. Then I have 2.09 is going to be midpoint between this and this. So this is 2.09. So I can get 7 of this. So this is 2.09, 2.092, 2.096, 94, 2.096, 2.098. So 2.097 will be in between this. So I'll put this and I'll draw this. So we have been able to get the point. So now we can join the points. We are going to join the points. So I'm going to draw a line of best fit. I can draw a line of best fit between these. Okay. These 3 values. Okay, we can go with this. I can go with these 3 values. Okay. So I'm going to draw my line of best fit within these 3 values here. So I'm going to have this. Now this is my line of best. So what I'm going to do is to draw a large triangle across this to get my slope. So my slope is going to be this. I'll read off this from here. I'll read off this value from here, this point. Then I'll read off this value from this point. I'll also read off this value from this point. And I'll read off this value from this point. So my slope is going to be, so let's read off this value. So this is 2.06, 2.062, 2.064, 2.066, 2.068, 2.068. So this is 2.02, 2.07. This is 2.072. So I'll read off this value here. So my slope equals 2.072 minus 1.96 divided by, so read off this. I have 0.008. So let me count this with 1, 2, 3, 4, 5, 6. So I have 0.0086 minus 0. So this I have 0.003, 0.003. So that's going to give me 2.072 minus 1.96. So I have 2.072 minus 1.96 equals 0.112 divided by 0.0086 minus 0.003 equals 0.0056. So let me divide this. 0.112 divided by 0.020. So this is in seconds. So I have second square and g, or I can say my slope is 20g second squared. So I have that. So this is the slope of the graph. There are other evaluations that are added there. You can carry out the evaluations yourself. If you like this video, please do ensure to subscribe and also share this video. Good luck as you write your WAEC on Friday.